Welcome to 5.2 transformations of sinusoidal functions. What that means is moving cosine and sine functions around in various ways, similar to chapter one's transformations. So we're going to start by looking at moving these graphs left, right, and up, down, and then we will be combining all our transformations together. This is another fairly long set of notes, so if you need to pause partway through and come back to it another day, that is totally acceptable. The first part that we're going to look at is what if we add a number at the end of our sine or cosine function? So not inside the function, but at the end tagged on outside the function. So just a reminder from chapter one, when that happens, that indicates that you are moving up or down. So if we wanted to take a look at sine x, I'll graph that in red. Sine x minus 1 and sine x plus 2. Sine x minus 1 is going to be down 1 from our original sine graph, and sine x plus 2 will be up 2 from our original sine graph. So notice we have not done any change in amplitude or change in period here. So these will all on the x-axis still go from 0 to 2 pi. We graph one cycle, and then 4 pi and 6 pi and 8 pi if we were to keep going. And on the y-axis, our amplitude is still 1. So what that means is our regular sine graph goes from -1 to 1. But when we want to move this down by 1, that means now it's going to go from -2 to 0. So that's going to move down. If we normally go from -1 to 1 on the y-axis and we move up by 2, now our maximum is going to be 3, and our minimum would be 1. So in order to figure out where I'm going to need to label these, if I have to go up to 3, I'm going to stick with what I was doing yesterday or on 5.2 and use 2 boxes as 1 unit. Okay. And on the x-axis, as long as our period can be split into 4 sections, we're good. So I'm going to make 8 boxes be 2 pi, 2, 4, 6, 8. This is going to be 2 pi. Pi would go in the middle. And if I did another 2, 4, 6, 8, this would be 4 pi with 3 pi in the middle. Again, as long as your 2 pi can be divided by 4, you're good. So I could have done 12 boxes or 16, and that would have worked as well. If I want to graph sine x, a reminder that this starts on the x-axis at the origin, finishes on the x-axis at 2 pi. We cross halfway between. We have a maximum between the first 2 points halfway, and our maximum is usually 1, and a minimum between the next 2 points halfway, which is at -1. If I wanted to do a second cycle, it didn't tell me how many cycles to do. Again, we would start at 2 pi and finish another 2 pi later, which is at 4 pi, cross halfway. Our maximum is halfway between the first 2, and our minimum is halfway between the second 2. We could connect that. I'm just using a dashed line to show that those are 2 different cycles. If I want to move this whole thing down 1, if I take a look at the solid line, I'm literally just going to take those 5 points and move down 1, not 1 box, 1 unit. So for us, 1 unit is actually 2 boxes. So my first point should now be down at -1, and same with all of my other points that were on my x-axis. Those should all now be down at -1. Our point that's at +1, our maximum when we move down 1, will now be at 0. And our point that's at -1, our minimum when we move down 1, will now be at -2. And we can draw this in. Again, if we wanted to do another cycle, I could do the same logic. Anything that was on 0 would now be at -1. My point that had been at 1 is now at 0. And my point that was at -1 is now at -2. So again, I'm just going to use a dashed line to show that this is a separate cycle. For our other graph, we have y equals sine x plus 2. If I go back to my red one, my basic sine graph, I'm going to move all my nice, neat points up by 2. So that's for us, that's 4 boxes. So anything that was on the x-axis now needs to move up to be at 2. My maximum was at 1. If I move that up 2, now I'm at 3. My minimum was at -1. If I move that up 1, up by 2, I'm now at 1. And I can connect. And again, I could do the same logic for the dashed part, my second cycle. Everywhere that was on an x-intercept should now be up at 2. My maximum now at 3. And my minimum now at 1. So what might make this a bit easier is, for example, if I was given a graph and asked to find my displacement, it's a nice visual to be able to cut this in half horizontally. So I would draw a line down the middle horizontally here, and you can see that this line is at y equals 2, which matches my displacement I had in my equation. Same thing if I take a look at my blue one and draw a line through the middle horizontally, that line is at y equals -1, which was my displacement of that sine x minus 1. So I like to do this visually. If I was asked what's the displacement given a picture, I would cut it in half horizontally. There is a nice little equation here you could use, which is max value plus min value over 2, but most of you will probably not use that at all. Moving on, we have our phase shift, and this is if you have a number inside your function with the x, with adding or subtracting. We know from chapter 1, having a number inside the function with the x means you are moving left or right. And a reminder that this is a little bit counterintuitive. So if you see something sine of x minus pi, this is actually pi to the right. And please note, this is not the same as sine x minus pi with no brackets. Sine x minus pi with no brackets would be moving down pi. If you had a plus, it would be moving up. So the brackets are really key to tell you that you're moving left or right. So again, we're going to try a couple of these. So if I had sine theta, we're going to graph that. We're going to graph sine of theta minus 2, all in brackets. So again, minus tells me I'm moving to the right, and we're going to move by pi over 2. The other one is going to be sine of theta plus pi over 3. So the plus tells me I'm going to move to the left, and we're going to move by pi over 3. And I find phase shift hardest for people to do, mostly because they don't get the right x-axis scale. They find it very hard to draw in their curve. So I like to go by common denominators, and it is sometimes not the best because it might not be the easiest way, and you might end up kind of doing a bit more work, but it will always work. So for example, what I mean by that is the common denominator here between moving left and right by pi over 2 and pi over 3, your common denominator between these two fractions is 6. So what that means is I'm going to make one box be pi over 6, which means 6 boxes is going to be pi. And the reason this is going to work for us is these do not have any sort of change in period. All we're doing is moving left and right. So if 6 boxes is pi, this means that 12 boxes is 2 pi, which is a whole period, and 12 can be divided by 4. So remember, when we're drawing this in, we want whatever our period is, the number of boxes we use, we want to be able to divide by 4 to make it easy to graph. So this is going to work for us if we stick with pi over 6. If this didn't work, then we might have to double it, okay? Or half it or something. But if I try this, this is going to work. 12 boxes is good for me. Okay? So 1 box is pi over 6. 6 boxes 3, 4, 5, 6 is pi, and 12 is 2 pi. So I could keep going. I could do another 12, 2, 4, 6, 8, 10, 12. That would be 4 pi. That would fit us in another cycle. Okay. And then we have to the left, we could do the same thing. 1, 2, 3, 4, 5, 6 is negative pi. We have no up, down. We have no change in amplitude. So this means that our maximum and our minimum are still 1, negative 1. Again, you don't have to use that scale. You could make one box worth 1, but I like to spread it out if I can to make it easier to read. If I draw in my regular sine graph, again, we know that we start at the origin, we end on the x-axis at 2 pi, we cross halfway at pi, and halfway between this would be 3 boxes. We're going to have a maximum of 1, and halfway between the next two, again, another 3 boxes, a minimum at negative 1, and we can draw this in. Oops, that last part. Again, if we wanted to do another cycle, we can, but it didn't tell us how many cycles we need, so I'm just going to draw one cycle for now. So if I wanted to move to the right by pi over 2, I need to figure out how many boxes that is. So if I'm moving right by pi over 2, the question is, what is this in terms of pi over 6, right? This is the same as 3 pi over 6. So this is going to be 3 boxes. Our other one that we have to move is left by pi over 3. And so the question is, well, what is this with a denominator of 6? This is the same as 2 pi over 6, which means we're going to move 2 boxes to the left. Okay, so if I want to do my right by pi over 2, I'm going to move all 5 of these nice, neat points on my red curve are going to simply move 3 boxes to the right. So the first one, if I move 3 boxes to the right, it's going to stay on the axis. It's just moving over. My maximum is going to stay up at 1. It's just moving over to the right by 3 boxes. In the middle, we're going to move again 3 boxes to the right. Our minimum, 3 boxes to the right. And our last 0, 3 boxes to the right. So it should not look like it has expanded at all. It should not look like it has been moved up or down. It should not look like any of that has happened. It literally has just shifted. And we can do the same with our left, but this time, instead of moving by 3, we're moving left by 2 boxes. So back with my original red curve, moving all my points 2 boxes to the left. So we can take all of these different transformations, phase shift, vertical displacement, as well as the ones from our last lesson, and combine them together. So just a reminder, a number in front of the function indicates our amplitude. So a vertical expansion or compression. A number inside the function in front of the x indicates a change in period. Which essentially looks like a horizontal expansion or compression. A number inside the function in brackets with the x indicates a phase shift, which is moving left, right. And a number at the end of the function, adding outside the function, is your vertical displacement, which is moving up and down. So note that we are working backwards to what we think. We're going to do any amplitude change and period change first. And you're going to do any phase shift or vertical displacement second. Also a note, as with chapter 1, anything that's affecting your horizontal expansion compression, or in this case our B, we must always factor out. Okay, so we've got an example of that here below. So we see that we have a B value in brackets instead of outside the brackets. So we need to factor this out. So if I do that, I have y equals 3 sine. I'm going to factor that 2 out and then have my brackets. And in my brackets, I now would have an x. I also have to factor a 2 out of the 2 pi over 3, because when I factor the 2 out of the brackets, it has to come out of everything. So this is now going to be pi over 3. And then I have plus 2. And now I can determine all of the things that are going on here. So I have an amplitude of 3. I have a B value of 2, which helps me with my period. My period is 2 pi over B, or 2 pi over 2, or pi. I have that I'm going to move by pi over 3 to the right. And I have that I'm going to move up 2. Okay. So our first and hardest part of this is determining what my scale is going to be. So I know that a basic sine graph has a maximum of 1 and a minimum of -1. If I change the amplitude to 3, our maximum would now be 3, and our minimum would now be -3. But now I'm also moving up 2. So our maximum is actually going to be at 5, and our minimum is going to be at -1. So that's going to help me label my y-axis. Okay. So if I label my y-axis, I need to have each box worth 1 because I have to make sure I get up to 5. So this highest point is going to be 6, or 2. Okay. Now, the x-axis is a little bit more difficult. I know that I need to be able to have my period, my pi, this guy, has to take up as many boxes as something divided by 4. So pi could be worth 4 boxes, 8 boxes, 12 boxes, etc. So pi worth 4, 8, 12, 16 boxes. You decide. Okay. Now, what's going to help us decide what would be best is because of the right by pi over 3. So I need something that can also be divided by 3 for my pi over 3. Okay. So I want some sort of common denominator between the pi over 3 and the fact that I need to split something into 4. So for us, that means 12 boxes is best. Okay. So pick 12. So pi over 3 works. Okay. If I pick 16 or 8 or 4, it's just not going to divide nicely. Okay. Or if I make pi over 3, say 9 boxes or something, it's not going to work because that's not going to divide by our 4. Okay. So 3 and 4, what's a number that's in common between those? 12. So I want pi to be worth 12 boxes. So 2, 4, 6, 8, 10, 12. That's going to be pi. And 2, 4, 6, 8, 10, 12. That would be another pi. Okay. It says at least one cycle, so we can graph 1 or 2. It's up to us. Okay. So now I also need to figure out, okay, well, if I've done that, where's pi over 3? I need to know how many boxes is pi over 3, right? So if I have that pi is equal to 12 boxes, the question is what is pi over 3? Well, pi over 3 would be 4 boxes, because this is the same as 4 pi over 12. And so this is going to be 4 boxes. So pi over 3 would be 4 boxes, which makes sense because 4 would be pi over 3. So another 4, that's 2 pi over 3. Another 4 would be 3 pi over 3 or pi, which is where I end up. Okay? So that works for us. So let's graph in our basic graph if we want to, or we can go straight to a change in period and a change in amplitude. So you have a couple choices here. You can choose to graph your basic sine graph and then graph a new graph, a second graph where you have a change in amplitude, change in period, and then move that. I like to just graph originally the change in period, change in amplitude, and then move that around. So I'm only going to have two pictures. So my basic sine graph, if my period is pi, I know I'm going to start at 0, end at pi, cross halfway. My change in amplitude means my maximum, which is halfway between the first 2 points, is now going to be at 3. My minimum, halfway between the next 2 points, is going to be at -3, and I'm going to draw this in. Okay, so the first one I've drawn here, okay, my first graph in red is sine x after change in amplitude and period. Okay, so basically what I've just done is I've drawn my vertical expansion and my horizontal compression. Then I can take this and move this left, right, up, down. So I need to move right by pi over 3, which was 4 boxes. So I need to move to the right by 4 boxes, and I'm moving up 2, which is 2 boxes. So all of my points need to move right 4 boxes, up 2 boxes. So this first point here, right 4 boxes, or pi over 3 units, up 2 boxes, or 2 units. The next one, right 4 boxes, up 2 boxes, right 4 boxes, up 2 boxes. So you can see if we connect these, this is that first hump of the sine graph. Then last 2 points, right 4 boxes, up 2 boxes, right 4 boxes, up 2 boxes, and I can finish connecting. Okay, so I've got some major points here. These are all marked on our graph. So just a reminder, our maximum here is 5, our minimum is -1, and we can find that using a little equation if we want. Your maximum is always d plus your amplitude, and your minimum is always d minus your amplitude. Okay. So when we graph these, the big key here is making sure you have an axis that's easy to work with. If you pick the wrong one, you can still do the question. It just might be a little bit more difficult. You also do not have to graph multiple graphs. You can go straight to the answer if you want. And in order to do that, you would need to make sure you still divide the x-axis to accommodate your phase shift and your period. So that's where we consider the denominator. Once we know that, if we've moved right by pi over 3 or 4 boxes, we know that we're starting there and we're ending an entire period later. So mark the start and the end of one period. We're going to split into our 4 even sections, and we need to make sure we've got all of our major points indicated. So those 3 middle points for sine and the max and the min. So we're going to try one more of these questions here. All right, so here we need to determine what is our amplitude, phase shift, moving up, down, vertical displacement, period. So here we see that we've got a negative, so our amplitude is still 1, but we do have a vertical reflection. And for cosine, what we know that means is instead of starting at the max and ending at the max, we're going to be flipped upside down like this. Okay. We have a b value of 2 over 3. So we can find our period is 2 pi over b, which is 2 over 3. So this gives us 6 pi over 2, or 3 pi. Okay. We also know that we are moving sorry, we're moving up 1, and we are moving left 3 pi over 2. So we know that we need 3 pi to be nicely divided by 4. So 3 pi boxes. 3 pi could be worth 4, 8, 12, 16 boxes. Now, because 3 pi over 2 is how we're moving, all of these can also be divided by 2. So that means that we could really use any of these. I'm going to want to pick maybe a bigger number just so that it's spread out nice enough so I can see all the points nicely. So I'll maybe pick 12 again, just because it's nice and easy to work with on this scale that we've got here, how big our graph is. So I'm going to make 4 boxes worth 1 pi. And that way pi over 2 is worth 2 boxes. And what that means is 3 pi over 2 here is going to be worth 6 boxes. Okay, so when it comes to moving left, right, that will help us figure out where we're moving. Okay. We also know that because our a is still 1, we only need to go up to 1 and down to -1. I'm also going to put some points on the other side here. This is negative pi, negative 2 pi. This would be negative pi over 2 and negative 3 pi over 2. Okay. And we can keep going if we want. This would be 4 pi, 5 pi, 6 pi, etc. Okay. So again, I'm going to draw in my little, what I call my ghost graph with my change in amplitude and period. So I know that for sine, or for cosine, sorry, normally I would start and end at the maximum, but because I have a vertical reflection, I'm going to start and end at my minimum. So my minimum is now going to be -1. I'm going to start and end here at 3 pi. My maximum is going to be halfway between. So halfway here would be 3 pi over 2. And then halfway between each of these is where my zeros are going to be. So 3 pi over 2 here was 6 boxes. So halfway is 3 boxes between each of these where my zeros are going to be. So this one here, this red graph, is after my reflection and my change in period. So 1 in red, after reflection and change in period. And now I have to move this thing up 1 and to the left by 3 pi over 2. So to the left, 3 pi over 2 is 6 boxes to the left and up 1. So my first minimum here that's on my y-axis, if I move to the left by 6 boxes, it's going to end up over to the left of my axis. And then up by 1 means I'm going to end up on the x-axis, because 1 unit vertically is 3 boxes. So what I'm doing really is I'm moving left by 6 boxes and up by 3 boxes. So my next point, same thing, left 6 boxes, up 3 boxes, and then left 6 boxes, up 3 boxes, left 6 boxes, up 3 boxes, and left 6 boxes, up 3 boxes. It's not a very neatly drawn. Let me. Okay. So we can see that our period, our cycle here is still 3 pi long. Our amplitude is still 1. We've flipped our cosine graph, but we've also moved the whole thing up 1 and to the left. Okay. So number 2 in blue after all transformations. So the red one has moved left and up. So again, if you're feeling like this is a lot of information, if you want, you could stop here for today and start some practice questions where you are graphing. If you're feeling like, you know what, no, I'm doing all right, you could keep going. The next couple questions are going to be working backwards, meaning I'm going to give you the graph and we're going to try and write the equation. Now, the hard part is if you're being given a graph, often there's an answer that works that's a sine equation, and there's an answer that works as there's a cosine equation. It really depends what you've been given, which one is easier. So it is handy to work with both. But I will be providing you multiple possible answers depending on what you see when you look at it. So for example, if I take a look at the sky, okay, we could view this as a sine curve. If I, for example, start from the middle and end back at the middle, that looks like a sine curve there. We also look like we might have a sine curve if we started over here to the left of the axis and end here. That looks like a sine curve. Okay. We might see a cosine curve if we start at the peak, the top, go down, and come back up to the peak. That looks like a cosine curve. Okay. We could also view this as an upside down cosine curve if we start at the bottom and end back at the bottom. So there's a lot of different ways you could view this. It really depends on what you see when you look at it. We're going to try drawing a sine and a cosine equation for both of these. So something to note. For both sine and cosine, your amplitude, period, and displacement will all be the same. The only difference is going to be phase shift. So let's determine these three things that are going to be the same no matter which way we look at this. Okay. So first, where's our midline? Well, our midline is on the axis, which means that we have had no displacement because that's where our midline normally is. Our amplitude is what is the distance up to one of the peaks or down to one of the valleys here, one of the humps from that midline. So our amplitude is this distance in here. This is our amplitude. So let's do that in a different color. Okay, or we can view it from the positive chunk here. That would also be our amplitude. So our amplitude here is 5. Okay. The other thing we need to determine is our period. Okay, so I always like to start right on the y-axis if I can. Sometimes the point on the y-axis is really not very neat and not great. So then I find it easiest to go from like maximum to maximum or minimum to minimum, like peak to peak. So I find it easiest for this one, I will go from peak to peak because our peak is on our axis. So this is one cycle, which is 4 boxes. So what we really need to figure out is what is our scale on the bottom. So we see that 1, 2, 3, 4, 5, 6 boxes is pi. So this means that pi over 6 is 1 box. So 4 pi over 6 is 1 cycle because it's 4 boxes, or 2 pi over 3 is 1 cycle or 1 period. So we have to figure out what B is. Okay? This is not your B, this is your period. So in order to find our B value, we know that your period is equal to 2 pi over B. And since we have 2 pi over 3, This means for us, B is 3. Okay, so we have a bunch of information. We have D and A, and we have B. The only thing we don't have is our phase shift, because it really depends on if we're looking at this as sine or cosine. So if I look at this as cosine, the nice thing is we'd be starting at the top, moving down and back up to the top, which means we would have no phase shift. So if we look at this from cosine, sorry, we're thinking here for a minute, there's no phase shift, which means C is 0. And what that means is we can write our equation as y equals, our amplitude is 5, cosine, our B was 3. We can use an x or a theta, it's up to you. Okay. We have 3x, and we have no d value, so we have nothing added at the end. That would be it. Our cosine is done. Okay. You could also say that you've moved right by a whole period. You could argue that there is an upside down version as well. Okay. But realistically, this is probably the one most of you would see if you were trying to see a cosine. Okay. If you're looking at it as a sine graph, most people will say, okay, well, here's where I see my sine graph right here. Move to the right. Okay. Let's darken this so we can see it. Okay. There's my sine graph. So if you're looking at as a sine, if there's no reflection, it looks like we've moved to the right by 3 boxes. Again, that does not mean we moved right 3. 3 boxes would be 3 pi over 6, because 1 box was pi over 6, or pi over 2. So if we want to write it from there, we could write this as y equals 5 sine. Again, our B is still 3, but now we're going to have brackets for a left-right shift here. And because we'd be moving right, this is going to be x minus pi over 2. Again, there are many possible answers. You might have said, that's not what I saw at all. You might have taken a look, seen instead, you might have seen that sine was over here. Okay, so your other option would be, what if you moved left by 1 box? You moved left 1 box, you would have 1 box is pi over 6. Okay, no reflection, but left 1 box. There's a couple of other answers that are on the PDF that I've uploaded where you might have viewed this as a reflection, and there's a couple other options you could have as well. So these questions are a bit easier because there's multiple answers, but also harder because there's multiple answers, because sometimes you might check your answer in the back of the book and go, well, that's not what I got, but it's because there were 6 or 7 options that worked. Okay, so these are just 3 in black here. These are just 3 different options you could have. So we're going to try a couple more of these. Some are harder than others. Okay, so we're going to just try and write one of the functions. And if you'd like to see the other options, you can look at the PDF copy that has been uploaded that has all of the possible options you might see. So the key thing here for this one is remembering that if I have a sine or cosine, okay, so if I have a sine graph, it's half of a period from the middle point to the middle point, and then the other half of the period is from the middle point to the end. If you have a cosine graph, you'll see that half of the period is from the maximum to the minimum, and the other half of the period is from that minimum over to the end, which is at another maximum. So you can see a half period in different ways, okay? So this one, you can't see a full rotation of your curve. You can only see a half rotation. But I can notice that a half period, it looks like it goes from this maximum down to this minimum, okay? This would be a half of a period. And I see that I have 1, 2, 3, 4, 5, 6 boxes is 90 degrees. So what that means is if I count how many boxes are here, I'm going to be able to figure out how many boxes is one period. Okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. So if 12 boxes is a half period, this means that a full period is 24 boxes. And since 6 boxes was 90 degrees, 24 boxes must be 360 degrees. Okay? Or 2 pi. So if my period is 2 pi, that means that my b is 1. Because my period is 2 pi over b, so my b must be 1. I can also find my amplitude, okay, and my displacement. So I can see that if I draw a line through the middle horizontally here, my d is -1. That line is at -1. And my amplitude here is the distance from a maximum or a minimum to my displacement. So my amplitude here is 1 box, which is half a unit. Okay. So no matter if I see this as a sine or a cosine, these numbers are all the same. What's going to change is if I can picture this being a sine or a cosine. I picture this as cosine, starting at this maximum point, going down to my minimum as this first half period here. And then my other half period would be over on the other side, coming back up over here somewhere. I see this as cosine that has moved left by 1 box. Okay. And again, if a full period is 24 boxes, a half period is 12 boxes, I can figure out how many degrees 1 box is. If 6 is 90 degrees, this means that 1 box would be 15 degrees. So I moved left by 1 box or left by 15 degrees. My program is just thinking here. All right. So what that means is my function would be y equals, my a is 0.5. I decided to use cosine. My b is 1. I don't need to write that down. I can if I want. And then my left needs to be in brackets with my x. Left would be plus, and I'm moving by 15 degrees. And my d is 1. Again, you might see this in a different way. If you view this as sine, you're going to have a different number in the brackets, okay? You view it as sine, most likely you would have started over here and gone up and down this way and ended here. And that would have been 1, 2, 3, 4, 5, 6, 7 boxes. You might also decide to change these to pies. So in the answers that I've posted in the PDF, I have a version where you're using degrees and using radians so that you can see both sets of answers. Okay. Last one here. Again, this fact that we looked at up here is going to be useful. So just so we can see it, I'm going to redraw it here because we can only see so much at a time. So from here to halfway, that's half a period. And here to the end is another half period. Or on cosine, from max to min is a half period. And from min back to max is another half period. So this one that we've got here, this portion from halfway to halfway kind of looks like this part of my sine. So again, I don't have any pi's on the bottom, so these are just regular numbers. I have 5 boxes is worth 5 units. Okay, and I have a half cycle or a half period is 1, 2, 3, 4, 5, 6, 7, 8 boxes. So this means a full cycle would be 16 boxes or 16 units. Okay, this is going to help us find, so this here is a half cycle. And this is going to help us find our b value. So we know that our period is supposed to be 2 pi over b. For us, this is equal to 16. So I need to find b. So what I would choose to do is multiply both sides by b and then divide by 16. So our b is pi over 8. That's going to be the same whether we're thinking about this in terms of sine or cosine. We also can draw in the midline here to these 2 points. That's going to give us our displacement and our amplitude here from our midline down to our minimum or up to our maximum. Okay, and we can see that this is 5. Okay. Now, part of the problem is we don't know where this graph is going off to the left. We can use all this information here that we just figured out using the period and such to find where it goes, but it's probably easier to see this as a sine graph that moved left 1 box and that has been reflected. So once we do that, we can see that this would be y equals, we have an amplitude of 5, but since we vertically reflect, this would need to be negative 5. And then we're going to have sine. We've got a b value of pi over 8. Inside of our brackets, we'll put our left 1 box. This could be x plus 1. And our displacement is 2, up 2. Again, depending on how you see this, will depend on what your answer is. So you might have seen this as a cosine graph that had been flipped and moved to the right. You might have calculated way over to the left off our grid there where that far left point would be and would have started for our sine. Okay, so this is probably the answer most of you would come up with if you were viewing this and trying to figure out is this sine or cosine. But again, we might have other answers. And last one, same thing. I can view this as soon as I see this minimum maximum business, I think cosine. So when I see this, I think, oh, this looks like an upside down cosine graph. Okay. And again, from mid points, I know that I've got a half of a period from my minimum to my maximum and a half of a period from my maximum to my minimum. So this here would be a half period, okay, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. Okay, and we know that 1, 2, 3, 4, 5 boxes is pi over 2. So what that means is a full period is 20 boxes, which would be pi over 2 times 4, or 4 pi over 2, which is 2 pi. So if I know my period is 2 pi, I know that b is 1, which is kind of nice. I can also see my midline here is at 1. And I can see my amplitude is 3. And so what I still need to decide is, well, that this looks like a cosine, an upside down cosine graph. I moved to the left by 2. If you see this as a right side up cosine graph, then it looks like we moved to the right by about 8 boxes, starting up here. Okay, I view this as a cosine graph moved left 2 and vertically reflected. What that means is I would have y equals, see, I have a negative out front because I've been vertically reflected. My a was 3. I chose cosine. My b is 1, so I don't need to include that. In brackets, I'm moving left, so it's x plus, and I'm moving left by 2. Part of the problem is I don't know what a box is worth right now. I can't do this part yet, okay? But I do know that 5 boxes is pi over 2. And what that means is 1 box would be pi over 10. Okay, so if I'm moving left by 2, that's going to be 2 boxes. So 2 boxes is going to be 2 pi over 10. And then I moved up 1 for my displacement. And I should fix that 2 pi over 10 there to be pi over 5 plus 1. Okay, again, you might have other answers depending on what you viewed this as. We can see my graph has kind of disappeared here and now it's thinking again. But you could very well have different solutions depending on what you see, okay? So I would always start with period, displacement, amplitude, because those are the same no matter what you see. And then after that, go for finding your left, right, up, down. These would be the hardest type questions because you cannot even see a full cycle, okay?